Here's the observation chart where I recorded my results in the third column. How did my results compare with your results? With these materials, light was either transmitted, reflected, or absorbed. To learn about those three words, you were supposed to go to Maggie's Science Connection to take notes and fill the chart below. Here's how I completed the chart. Definition for transmit. Light passes through a material or substance. What happens to light? With transparent objects, light is easily transmitted through. That means all light passes through. With translucent objects, only some of the light is transmitted. The rest is scattered. An example of a transparent object that let all the light through was a clear cup or plastic wrap. A translucent object that only let some of the light through. An example of that was notebook paper. The definition for reflect is light bounces off a surface. No light is transmitted, and some of the light is actually absorbed. An example of an object that reflected light, the mirror and the aluminum foil. If you remember from the experiment, the light did not go through the mirror, but bounced off back at us. The definition for absorb is light is taken in by the material or substance. Light hits the surface and is changed to heat energy, and you know that because the object feels warmer. An example of an object that absorbed the light was the book and a piece of cardboard. The next step in the experiment was to create a new chart classifying the materials based on the results. You had to sort the materials based on if they transmitted light, reflected light, or absorbed the light. And for the items that transmitted the light, did they transmit all of the light or only some of the light? Here are how I classified the materials we tested. Transmitting all of the light, the plastic wrap and the cup of water. Transmitting some of the light, the tissue, the paper cup, wax paper, your hand, and note paper. Objects that reflected the light were the mirror and aluminum foil, and objects that absorbed the light were the cardboard, the pencil, and the book. For the Energy of Light Day 6, we're going to continue investigating what happens when light meets matter. We classified the objects yesterday as how they interacted with light. Did they transmit the light? Did they absorb the light? Did they reflect the light? Today, you're going to continue exploring these materials and discover there's another way to classify these objects. The materials we tested were all transparent, translucent, or opaque. Watch 2 short videos exploring light and light and shadows by clicking on the links. As you watch the videos, take notes and then fill out the chart below. This picture shows 3 cups. Even though they're all cups, the amount of light that passes through each one is different. Why? Pause the video and think about it. Now that you know what transparent, translucent, and opaque mean, it's time for a challenge. Sort the materials based on those properties. The next step is to read the passage on reflect, absorb, and transmit, and highlight essential information. Today's experiment continues to explore what happens when light meets matter. When you are outside on a hot, sunny day, what color clothes should you wear to stay cool? Pause the video to think about it. To remember what happens to light when it meets matter, think RAT. Reflect, absorb, and transmit. What happens to light when it is absorbed by matter? Pause the video and make a guess. If you said light is changed to heat energy, you were correct. But how can we tell this is actually happening? That's what we're investing with today's experiment. The objective for today's experiment is to observe what happens when light is absorbed by matter. The key words are absorb and heat energy. The materials you need to collect for today's experiment. You need 2 identical drinking glasses or jars, water, a thermometer, and our thermometer we use to measure our temperatures, we only have a forehead and ear thermometer. This is actually a meat thermometer because Mr. Motor likes to smoke meat, and it worked really well to test the temperature. 2 elastic bands, jar bands, or tape. You needed white paper, black paper, a sunny day, and a sunny spot. Remember, if you do not have these materials, make the best predictions possible to answer different questions. The first step is to wrap the white paper around one of the glasses using a rubber band or tape to hold it on. Just wrap it around the cup, and then you can secure it with a rubber band. If you don't have a rubber band, you can use tape. You do the same thing with the black paper and the other glass. Then you fill the glasses with the exact same amount of water and place them in a sunny spot. When you fill the glasses with water, do not fill them all the way. In fact, do not even fill them halfway. If you fill the cup to about a third to a little bit less than halfway, your results will better show what I want you to see in this experiment. After you have your cups in a sunny spot, you're going to measure the beginning temperature of both cups of water. You're going to record this temperature and the time in your prediction and observation charts. We're going to begin by making predictions. Do you think the white or the black cup will have a higher temperature after a couple of hours in the sun? You're going to type your choice into your Google Slides. The next step is to fill out the prediction chart. After taking the beginning temperature of your white cup and black cup, you need to guess what the end temperature might be. My beginning temperature for my white cup was 77.5 degrees. Actually degrees Fahrenheit. Instead of writing degrees Fahrenheit, I'm going to show you a trick that you can use on your Google Slides. If you go to Insert and select Special Characters, you're going to type in degree into the search box. And new selections will pop up. We're going to choose the second one for degree Fahrenheit. You click. Because my cursor was next to the 5, it inserted the degree Fahrenheit right next to my temperature. The next step is to make a guess at what the predicted end temperature would be and add it to this box. Finish completing out the chart for the black cup. The next step is to leave the glasses out in the sun for a couple of hours before returning to measure the temperature of water in each. Every time you check the temperature of the water in your white and black cup, you need to record that information on your observation chart. The time I began my experiment was at 9 a.m. The beginning temperature of my black cup was 77 degrees Fahrenheit. The temperature of my white cup was 77.5 degrees Fahrenheit. It doesn't matter that one is slightly higher than the other, because what matters is the end result. How much will the temperature of the water increase over the day, and which cup will increase more? I decided I wanted to check my cup at 11 o'clock and 1 o'clock. Actually, when I conduct the experiment, I'm going to check it every hour. I'm going to check it actually for about 7 hours, from 9 till about 4 o'clock in the afternoon, just so we can really see how the temperature of the water is affected throughout the day. You should pick times that'll work for you, but it's best to pick times, one in the morning, one midday around lunchtime, and one early afternoon. After you complete the experiment, use the information in your observation chart to answer these questions. Was your prediction correct? The next question asks, which cup had a higher temperature at the end of your observation period? And the third question, why do you think this is? The last question asks, what do your results tell you about light being reflected or absorbed by black and white objects? Think about what you've learned over the last couple of days, how light interacts with matter. Today's experiment was just one way to investigate the absorption of light turning into heat energy. Here are 3 more ideas for you to test on your own if you want to do some more experiments. And the last step for today's lesson is to read the passage on light, color, and heat and highlight essential information. I look forward to comparing my results with your results tomorrow.